Hello, Tom from Every Step Calculus, EveryStepPhysics.com. Before we get into the video problem, I'm in a holiday mood right now, so I'm offering my Calculus 1, 2, 3 programs for only $5 through December. If you subscribe to my site and send me $5 via my personal email of tomtrumpet4@gmail.com, that's TOMTRUMPET, the number 4, @gmail.com. And these are the same exact programs that I sell normally for $40, so it's quite an offer here for December. Now the Riemann sum problem. Let's do it. Index 8 to get to my menu. And I'm going to scroll down here now to Riemann sum. It's all alphabetical, so there's 135 programs here. If you were to scroll down, you'd hold this second key down and then press this bottom arrow, and it would go screen by screen quickly down to get to the R section here. And Riemann sum, look for Riemann sum. There it is there. Press enter. And I'm going to give you the formula. You write all this stuff on your paper because this is all important. I'm going to enter the function. You have to press alpha first. We're going to press alpha 16 minus x squared. I check to see if it's correct. It is, so I'm going to press OK. I'm going to enter the range. The range is alpha 3 and alpha 4. Again, I say it's okay. We're going to enter the amount for n. Well, in this problem, they ask you to for the number n number 4 and n number 6. That's a number of times you do the calculations. So let's do the number 4 first, okay? So I'm going to press alpha 4. So n is equal to the bounds of summation equals 4, and I equals the index of summation. I is 4, actually 1 to 4. And they ask, let's see what the approximate area region using right endpoints. So we're going to use number 2, right. That's a special formula. The formula has a little difference. I'll show you that in a second. And so you do the formulas just like you see on the screen here. We do the calculations. Here's the formula for each one of the iterations. 7, 2, 15 fours, number 4. And then we put it into the actual formula, what we just found beforehand, which is 16, and then we have x squared here, so you just solve for x or substitute for x. And then each one of these. And here's the formula here again. And here's the answer. Capital S is that you do it on the right and you're doing the upper sums. Small s is left, and the small sums. 8932 is the answer. Of course, you know, approximately 2.78. Let's go back and do this. The number 6 for n. We have to enter the formula again. Alpha, or the function, 16 minus x squared enter the range, alpha 3, alpha 4, it's not right, let's change it. It was 4, 4, I made a mistake, sorry. Alpha 3 and alpha V4. That's better. Say it's okay. For M, or N, is alpha 6. So we have the 6 for n bounds and 1 to 6 for the index, okay? This is to the right. And we do the calculations. B, the change of x is equal to b minus a over n, okay? And that's n is 6, and the upper minus the lower is this one, okay? Equals 1/6. These are the calculations. How'd you like to do this without the program, huh? You want to try this? Nonsense. All nonsense. We put it back into the formula. Solve it with the formula, all these figures here before. And we look at, and the answer is 665 over 216 and 3.08 as approximation of the answer. Now, these are sigma sums that you're doing here. Now, a lot of professors will say this is Riemann, but it's not really Riemann in my estimation. It's sigma sums. Riemann is if you have n to infinity, okay? So, no big deal. I don't like to teach calculus. I just like to show you how to do the problem so you can pass your tests. All right, think about taking advantage of my offer, and happy holidays. Have a good one.